So guys, next we will going to discuss the MAC addresses. So what are actually MAC addresses and what are they used for and what is the format of MAC address? That's all we will going to discuss in this slide. So within a subnet, data transmission across machines or between machines is done using only MAC addresses. So note this point that whenever the communicating machines belong to the same subnet, the data delivery is done using only MAC addresses. The IP address do not play any role in data delivery whenever the communicating machines belong to the same subnet. So thus data link layer operates with MAC addresses only. So remember that whenever the communicating machines present in the same subnet, only the data link layer of the TCP IP stack is responsible for data delivery from the source machine to destination machine. And only MAC addresses are used for this data delivery. IP addresses hardly play any role in L2 routing. IP addresses are not used for data delivery between communicating machines which are present in the same subnet. And that is the reason that MAC addresses are also called layer 3 addresses, and MAC addresses is used by the data link layer, whereas IP addresses are also called layer 3 addresses, and IP addresses is used by the network layer for routing the data between machines present in different subnets. So now the question arises that who actually has MAC addresses? Who assigns the MAC addresses and how can we configure MAC addresses? And how does the MAC address looks like? So let us discuss all these nuances of MAC addresses. Now, every interface through which a device is connected has a MAC address. So far we have learned that interfaces has IP address and mask value configured on that. In addition to the IP address and mask value, the interfaces are also configured with the MAC address. So you can see in this diagram that each interface of a device has a MAC address. So interface A of device A has a MAC address MA. Similarly, you have the MAC address MB, MC and MD. So these MA, MB, MC and MD are only the symbolic representation of MAC address, just for convenience. How the MAC address looks like? The MAC address looks like something like this. I will show you shortly the actual MAC addresses by using some Linux command. So who assigns the MAC address? The MAC address is assigned by the device manufacturer, right? So you cannot configure or change the MAC addresses of a device because the MAC address is assigned by the device manufacturer only. That is, at the time when the device is being manufactured, the device manufacturer assigns the MAC addresses to the device. So you can see, suppose the device A is a printer and this printer has an interface if A, so the company which is manufacturing this printer can assign the MAC address, let's say this, to the printer A, and this MAC addresses is burnt. Note the word, this MAC addresses is burnt inside the hardware and you cannot change it for the entire lifetime of a device. So MAC addresses is also globally unique. It is burnt in the hardware and you cannot change it. You don't have any control on the MAC addresses. So MAC addresses are configured on the interface. So if the device has n number of interface, it means that the device has n number of MAC addresses. So you can check the MAC address and IP address of your VM router using ifconfig command. So you can try the ifconfig command, and this command shows you the MAC address and IP address configured on all the interface of your Linux machine. So let me show you a simple demonstration. So let's say this is your Linux virtual machine. Just type out the command ifconfig and it will show you all the interfaces which are present on your Linux machine, and against each interface it shows the MAC address. So MAC address is listed here, and it is also called hardware address, or the MAC address is also called the physical address, whereas IP address is also shown here, which is configured on this interface, and IP addresses is also called the logical addresses. And with every IP address we have a mask value, so you can see the mask value is configured here, right? So you can see that each of these interfaces are configured with the MAC address. Of course, we can change these MAC addresses here, because at the end of the day these interfaces are simulated by our VirtualBox software, which allows you to configure the MAC addresses also. But on an actual physical machine or on an actual physical router which have real interfaces or network interface cards, these hardware addresses are burnt inside the interface cards and you cannot change it. So let us discuss the representation of MAC address. So MAC address is a 6-byte number. So, and a byte is also called as octet. So you can see that the MAC address is 6-octet number. It has 6 octets, means 48 bits, right? So the representation of the MAC address in the hexadecimal format is as follows. Just convert each octet of the MAC address to the equivalent hexadecimal number, and what you will get is the hexadecimal representation of the MAC address. And to convert the MAC address into its equivalent binary format, just convert each octet of the MAC address into its binary equivalent, and what you will get is the binary representation of the MAC address. So remember that the MAC address are 48 bits addresses. Now let's discuss next the IP addresses and the subnet mask. So every interface through which a device is connected has an IP address and a subnet mask also. That is, besides MAC address, every interface also has an IP address and a subnet mask value configured on it. But unlike MAC addresses, IP address and mask addresses configured on the interface is configurable and you can change it as per your wish. For each interface, you have to configure an IP address and mask value. So if a device has an interface, then you can configure an IP addresses also. And again, you can check the MAC address and IP address configured on various interfaces of your machine using ifconfig command. So you can say in this example, every interface of a device, whether the device is a router or the device is a host machine, every interface is configured with the MAC address and the IP address. And of course, the interfaces has name, right? So the MAC address need not follow any particular pattern. It can be any random number as per assigned by the device manufacturer. But the IP addresses that you configure must follow certain rules. And what are those rules? The rules are that all the machines which are supposed to be present in the same subnet must be configured with the IP address such that all of those IP address gives you the same subnet ID or same network ID, right? So MAC address could be any random number. It need not follow any particular pattern. But the IP address on the other hand has to be configured by the administrator, and they have to be configured systematically as per some scheme. So let us discuss the representation of IP addresses. So IP addresses are 32-bit addresses, which is also 4-byte addresses or 4 octets, right? So let us take an example of an IP address. Let's say the IP address is 60.166.56.227. So the decimal representation of the IP address is very simple. Just represent each octet separately in decimal notation. So this is the decimal representation of a IP address. And if you convert each octet of an IP address into its hexadecimal equivalent, then you will get the hexadecimal representation of IP address. So you can see that the decimal number the second octet, that is 166, has been converted from its decimal notation to hexadecimal notation, which is A6, right? So this is how you convert the IP address from one form into another. Similarly, the fourth octet of this IP address, that is 227, has been converted into its equivalent hexadecimal value. So as a result, finally you get the hexadecimal representation of IP address. Similarly, in order to obtain the binary representation of an IP address, just convert each octet of an IP address into its binary equivalent independently. And what you will get is the binary representation of IP address. So remember that the length of the IP address is 32 bits.